right, so I realized yesterday as we were talking through things that I did not do, what the heck, no. Oh my gosh, that I don't know how to work YouTube apparently. It's not the one I want. It's the one I want. It may
We
not.
start with a circle.
No. Okay. We're going to start with the circle. I'm going to turn that down a little bit. But what I realized is that I didn't do a great job of kind of re-explaining to y'all what a radian is. I said it. We did it in geometry, but we spent one day on it and then like moved on quickly because all that you really have to do in geometry is convert from degrees to radians. It doesn't even say in there that we have to explain to you what one is. We did, but that doesn't mean that it stuck with you. But it's important for you to understand the connection to arc length because arc length is something that you do in geometry. It's just a part of the circumference, right? So an angle measure is in degrees, right? So you can have a max of 360. And arc length, since it's a length, can be anything because it's like part of circumference. But we deal with everything on the unit circle. So really the unit's just 1. So we go from 0 and then the circumference would be 2 pi r and the radius is 1. So we go around 2 pi times, right? But this little animation here kind of is good to show you what a radian is. And he talks you through it a little bit. I'm only going to show you 30 seconds of it. The rest of this little video, it's a minute and a half. It's not a long one. Long math videos are never good. But it talks you through kind of what we did yesterday with the whole converting thing and whatnot. So if you want to go back and watch it, it's in the playlist, and I stuck another one that's like a minute and a half in the playlist, which is another animation. I just felt like it was kind of busy on the screen. I think that this one probably is the best one. So let's see if I can actually make this work this time.
Circle of radius r. We take that radius distance and wrap it around the circle. The angle formed by that radius distance is 1 radian. Since the circumference of a circle is 2 pi r, there should be 2 pi radiuses in a circle. So halfway around the circle, we would expect 1 pi radian, and around the entire circle, we would expect 2 pi radians. We start with a...
Okay, so does that kind of make sense? How it's related to the arc length. It's not really an angle thing. But even though arc length can be large numbers, it's not when we're talking about a unit circle. So 360 degrees around is 2 pi radians. And if you do that, since it's a ratio between arc length and the radius, then it ends up canceling out anyway. And even if you have a ginormous arc length, when you divide it by the radius, you're just going to get something that can't be more than 2 pi anyway, with one rotation anyway. So it's just a part, you just take that radius and bend it around the circle, that's 1 radian. You good with that? For the most part, what a radian is? Y'all are just staring at me like I'm crazy, so I don't know. Okay, all right. Okay, you can go back and watch that again, and it explains it a little bit more, but that's just kind of the generic thing. So now we're going to look at how this is going on the unit circle. We're going to go back to the blue one, but this one is going to go on page 99 when we're done. And we're going to start in this blank space right here. We're just going to sketch part of a unit circle. And I know you have one to look at, but you need to be able to eventually kind of sketch it in your brain, but at least be able to sketch it out on a blank sheet of paper here. And we're only worried about the first quadrant. If you can get the first quadrant down, you can do the rest, piece of cake. So I'm only even going to draw like 1/4 of the circle anyway. So we're just looking at the first quadrant. We know that this is 0, right? This is 90. Halfway between 0 and 90 is what? 45. And then if I go 1/3 of the way, I'm at 30, and then I'm here at 60. And so these are my special angles. Remember special right triangles, they have all the special angles there. And you can, draw that in like that if you want. Because I know it has little lines on your actual unit circle. Okay, so here's what we know about radians. We know that at 0, it's at 0, right? 0 radians. We go all the way around, that's 2 pi. So to 180 is how many radians? If all the way around is 2 pi. Pi, right? So 90 has to be what? Pi over 2, okay? We can reason our way through that easily, yes? All right, so 30, if we know that 90 is pi over 2, we talked a little bit about this yesterday, but again, we need to be able to rebuild it. To get to 30, how far is 30 on your way to 90? It's a third of the way, right? So 30 degrees is a third of 90. So the radians here has to be a third of pi over 2. So what would that end up being? Pi over 6. So 30 is pi 6. Right? So we have over here, we can put in 90 is pi halves. 30 is pi sixths. And then 45 is how far? Halfway. So half of pi halves is pi fourths. Right? If you can get at least those down, the rest is a piece of cake. Because, yeah, 60, you can figure out how far 60 is from 90, and that's not complicated. But if you know that 30 is pi sixths, isn't this just another 30? So isn't this 2 pi sixths? Can you reduce that? And it's pi thirds. So pi thirds is the real answer, but that's the whole counting thing that we kind of talked about yesterday. And then guess what? 90 is 3 pi sixths, which gives you pi over 2. If you can at least commit these to memory, the rest is just a matter of understanding multiples, right? So the rest of what we have down here, we're going to work through some of these. I'll have you work through some of them too. And there shouldn't be any work. You look at your denominator. Now I'm going to have to, well, I don't have to scroll too much for this one. But let's look at 5 pi over 4, right? So I know that 45 is pi fourths. And this is how many pi fourths? It's 5 pi fourths. So I'm not doing the whole conversion thing like we were doing yesterday. We do that when they're not the special angles. If pi fourths is 45 and this is 5 pi fourths, isn't this just 5 times 45? Does that make sense? And so 2 times 45 is 90. So 4 times 45 is 180. So it's really just 180 plus 45, which is what? 225. And there's your conversion without doing your 180 over pi. Does that make sense to you? If y'all can't ever see, will you let me know? Like that box yesterday, somebody was, is this in your way? Yes. Well, then it's in your way every day. So tell me, or if I'm in your way, tell me to try to get out of the way. I didn't realize the box was always in the way. All right, so let's look at 2 pi thirds. All right, well, pi thirds is 60. This is 2 pi thirds, so that's 2 times 60, which is what? 120. You with me on that? You want to get, and you will get to a point where if it's 2 pi thirds, you just know it's 120, but until you get to that point, you think about the multiples, all right, especially if it's some obscure number. All right, so negative 7 pi sixths. Well, the fact that it's negative, is that going to change? No, so it's still going to be negative, right? So negative. Pi sixths is what? 30. So this is 7 of the 30s, which means that's negative what? 210. You see how that works? You do the next two. Oh my gosh, that's loud. All right, Kevin, what'd you get for 3 pi halves? 270. Y'all agree with that? Okay, pi halves is 90. You want 3 of those, so that's 270. Good job. All right, and then 5 pi eighths. Oh, 5 pi eighths. Oh, I'm making up numbers. 8 pi thirds. Whew. All right, Demi, what'd you get for 8 pi thirds? 480 degrees. Y'all agree with that? Very good. Yes. Because pi thirds is 60. You need 8 of them. 8 times 60 is 480. Everybody good with that? A little less work than the whole pi over 180, 180 over pi thing. Plus, these are things that you just got to know on the fly. All right? So some of this stuff with the unit circle that we're going to do over the next couple days, we're not actually going to use over the next week or so because wanted to do this early so it had time to marinate in your brain and you had time to practice so that when you do have to know it on the fly, you know it. Instead of us giving it to you and then you have to know it on the fly the next day. Does that make sense to you? So it's going to seem like maybe some of this we're going to be applying and some of it we're not over the next week or so, but we are. So don't think that I'm lying to you about that. I just wanted to make sure that you had time to let it kind of soak in. All right, so the whole degrees to radians thing. This, we're doing the same thing but opposite. So your special angles are 30, 45, and 60, and then 90 kind of counts too, right? But if it ends in a 5, it's not 30 or 60 or 90, right? So this has to be a multiple of 45. So how many times does 45 go into 135? Okay, so twice would be 90. What's 90 plus 45? 135. So it goes in there 3, right? So what is 45 as radians? Pi over 4, right? And how many 45s is this? 3. So this is 3 pi over 4. Bam. There you go. Okay? You have to think. You have to know, you know, like your multiplication facts and stuff to be able to do this. All right. So 300. 300 it's divisible by a couple of things, right? And it doesn't really matter which one you do, but if you do the largest one that divides into it, it comes out a little bit nicer, but it's not wrong. You would just have to do some reducing on the other. So we'll actually look at this both ways. Negative 300, so first of all, so that we don't get lost in everything else, we know it's going to be negative, right? Does 90 divide into 300? No. Does 60? Yes. Okay, so what's 60 as radians? Pi over 3. Okay, so how many times does 60 go into 300? 5. So this is going to be negative 5 pi over 3. But let's say that you looked at this and you're like, oh, clearly that's 30, right? So we would do negative. Well, what's 30 as radians? Pi over 6. How many times does 30 go into 300? 10. So this would give me negative 10 pi over 6. And then when I reduce it, that's what I get. Okay, so as long as you reduce it all the way, even if you use a different multiple, as long as you're right, you're good. But if you can think of the biggest one, then it's going to make it the easiest because you're directly there. Okay, we good with that? All right, so 150. What would we divide into there? 30. We go with 30, right? So that's pi 6. How many times does 30 go into 150? 5, right? So this is going to be 5 pi over 6. All right, do the next two. Christy, what'd you get for 9? 5 pi over 2. Okay, what did you use as your divisor? 45. Okay, so when you did that, 45 goes in there 10 times, right? So you get 10 pi over 4 because that's what you almost said, right? Which that's fine. That's fine. You got 10 pi over 4, which you know in the end then is 5 pi over 2, right? And when you divide, that's when you know, oh, okay, what could we have used to get this directly? 90. Okay, what else goes into 450? Does 60 divide in there? No. Does 30? Yeah. So this could give me 15 pi over 6. But guess what? That reduces to that as well. All right. But the biggest one will get you directly there. But you being able to reduce fractions shouldn't be a big deal at this point, I would hope. Okay. So then the last one. Katie, what'd you get for the 330? 11 pi over 6. Y'all agree with that? Yes. 11 pi over 6. Good. So do you see how to kind of handle them? We're not doing a direct conversion like with your conversion factor. I would do that for angles like 335 or something that wouldn't have something that would divide into it. Okay, we good? All right, so we're not 100% done with this, but I want to go and work on the circle before we come back to this. Yes? Yeah, probably. So if you just have an angle and I give you 155, well, if whatever angle I would give you, you want to run through, can I divide that by any of my special angles? If the answer is yes, you have it immediately. If the answer is no, then you're going to have to use the conversion factor. Does that make sense? Mm-hmm. You're going to get the same answer? Yeah, it totally works. Because some of the ones, actually, I realized that I think all the examples I did yesterday ended up being special angles, and I didn't mean for that to happen. That's why I made you go through the math anyway, because we talked a little bit about how to think through this. So you'll still get the same answer. You just don't have to do it, and the idea here is that you're going to need to know these on the fly, that you're not going to have time to always do that, or you don't want to have to always do that. But this is just like anything else. The more you do it, the more practice you have, the more you'll recognize them, and you'll be able to just kind of look at them and know that they're special angles. Even if you don't know exactly that it's 5 pi over 3, you'll remember that 300 is a special angle, and you'll be able to figure it out that way. Does that make sense? Okay, it's a good question. Anything else? All right, so let's look at the circle, and let me see how I can make this circle. Yeah, okay, I know my numbers are super tiny. Now, I had these 4 boxes here because this is how this was originally set up for a different set of notes that I had, and we left the boxes on there because we thought, well, maybe we'll have something to write in there. I don't know that we necessarily have anything to write in there, but so they may stay blank and it'll just look weird, and it's okay. But right here, we just have the first quadrant even labeled at all. So let's just fill some of this stuff in. At 0, we know it's 0 radians. At 360, how many radians do you have? 2 pi, right? So here, this is 90, and it is pi over 2. Right? So without looking at your other paper, let's try and get these filled in. 30 is how many radians? Pi over 6, good. And 45 is pi over 4, and this is pi over 3. Okay, so that right there, that has got to be committed to memory, 100%. The rest, kind of yes too, but especially that so that you can, for now, kind of think through the rest. So let's come over here and do 180. Oh my goodness. Sorry, just all over the place today. Hi. All right, and then what is this down here in degrees? 270. And that would be 3 pi over 2. Good, because remember, you can count this way too. This is 1 pi over 2. This is 2 pi over 2, which is pi. And then this is 3 pi over 2. Just always reduce it all the way. Here's the other important thing for you to see here, is that when these are all connected, do you see how this is just one continuous line segment? Which means from this point right here around to this point is a rotation of how much? 180, right? So from here around to here is 180 degrees. So 180 degrees is just pi. Well, this is pi sixths, right? If I want to add 1 pi to it, I have to get a common denominator, so that's 6 pi over 6, right? So if this is pi sixths, what is this one for sure going to be? What's pi sixths plus 6 pi sixths? 7 pi sixths, because you're just adding the 180 to it. Does that make sense to you? Just add in that 180. So if this is 30, what does this angle have to be? 30 in degrees. I'm adding 180. 180 plus 30, 210. Okay. You see how that works? You're literally just adding 180 degrees in radians and in degrees. So 45 degrees plus 180 is how much in degrees? 45 plus 180 is 225, okay? And then pi fourths plus 4 pi fourths is 5 pi fourths. $60 plus 180 is 240. And then pi thirds plus pi is 4 pi thirds. So you see how to build that? Now, these don't even have degree measures on them, and I don't want you to be assuming, like these we know for sure because we got the whole 180 thing going on. But this is a reflection, right? We've got a lot of symmetry going on here. So if this right here is 30, this right here is this is 30. What would I call this angle going from here to here? Just that part. The reference angle. Good. Because the angle in standard position starts here and rotates around to here, but then the shortest way back to the x-axis, that's the reference angle. So if this is 30, this reference angle is 30, which means in degrees, what is this actual angle here? 150. And then you can think of this a couple of different ways. It's 180 minus that 30, which means it would be pi minus the pi over 6. But we can also look at it a little bit differently. So let's go ahead and look at the other angles first. So if this is 45, this reference angle is 45. What is this angle right here in degrees? 135. And then what is this angle right here in degrees? 120. So I know you don't love fractions. Some of you may never will. Adding them wasn't that big of a deal. Subtracting, I have a feeling some of your brains would go a little wonky on that. So let's look at it. We'll look at it a couple different ways. Because again, you can do pi minus the pi sixths, right? So it's really just 6 pi sixths minus 1, which would give you what? 5 pi sixths, right? Not that big of a deal. So let's go ahead and write that. But then let's look at it a different way. The whole counting thing, we talked about it a little bit yesterday. This is 30, so it's 1 pi over 6. Another 30 is 2 pi over 6. 3 pi over 6, another 30, 4 pi over 6, then we get to 5 pi over 6. So it takes a little bit more counting, but you can also just subtract from the reference angle. So let's try the subtraction, but you can count the other way. So 135, right? The reference angle is 45. So pi minus pi fourths would be what? Because it's 4 pi fourths minus pi fourths is 3 pi fourths. For that 120, what's my reference angle in degrees? 60. So I can take pi and subtract 60, so that means pi minus pi thirds is what? 2 pi thirds. But again, I go 60, I'm at pi thirds, another 60 gives me 2 pi thirds. Guess what? Another 60 gives me 3 pi thirds, which is pi. Then I get 4 pi thirds, which is another 60, and then keep going around that way, okay? So I want you to fill in these three with degrees and radians. All right, so you get 300, right, because I'm here at 270. I'm going to add another 30, because every time it's 30, and then 45, and then 60 added to it. So, bam, there we go. All right, so 300. What is 300 for your radians? What's that going to be? How many? Okay, 300. How many 30s is that? 10. How many 60s is that? 5. Which one's easier to use? The 5. So if this is 5 60s, that is going to be 5 pi over 3. $3.15. 7 pi over 4, because it's 7/45s, right? And when you have the circle, you don't have to really think about the dividing. You can literally count, and it is 7, and it is 7 pi over 4. 330, 11 pi over 6. The more that you can commit this to memory, the better off you are. Memorizing works well for some people, not so much for others. I think overall, memorization is just it's kind of a trick. You learning it and knowing it and understanding how to build it and how to come up with it helps you know it. And knowing it's a little bit different than memorization. If you need flashcards, do that. But that's just some random number. If you understand how it works on the circle and how it's related and how you can add 180 or subtract the reference angle, then you'll learn how to kind of do that in your head a little bit quicker and understand which, thank you, understand which quadrant you're in and whatnot. Okay? We're good? Any questions on this? Tell me what you just said, her. Oh, yes. Yes, good. Okay. So I figured if she had a question, probably other people would help too. So no, that's good though. So I got these by asking you like how many of these were in there, but you can do it the same way as you did over here, adding the 180. This 120, which is 2 pi thirds, okay, here's your 180, bam, right there. So if you just add, again, that's 180 degrees, you add pi to it, so you have to add 3 pi thirds, that's where you get your 5 pi thirds. This 3 pi over 4, you add pi to it, which would be 4 pi over 4. That's where you get 7 pi over 4. Here you add pi to it, which would have to be 6 pi over 6. That's where you get your 11 pi over 6. So there's multiple ways to think about where it comes from. You have to figure out what makes the most sense to you. Because what makes the most sense to you might not make the most sense to your neighbor. Like the way you build it may be the different way that your neighbor builds it. So you need to kind of at least understand how it all works so you can decide what makes the most sense in your brain. Okay? Anybody have any other questions or comments about this? Are you thinking about it, or are we just... Okay, we good so far? Because we're going to keep coming back to this, and this is kind of the whole drill and practice thing. You want to be able to get to it where you can do it quickly and not really have any work behind it. Okay, we good so far? All right, so now take your pink one, and I want you to fold it in half. We're going to talk a little bit about... Go back to, that is not the one I want. Oh gosh, okay. So, I guess what you can title that, well, what you want to title it, because on the outside too, just, let's see, special angles. Oh my gosh. I put this on the outside because it's what it says on the inside, but I want you to know what's on the inside too. And we're also going to look at some trig ratios, because tomorrow what we're going to do is we are going to look at the unit circle a little bit more, look at it with your special right triangles, which were drilled into your brain like crazy in geometry. And we're also going to look at, it's okay, you don't have to have this back out, I just want you to see it for a second. We're also going to look at, see these points? All these points have ordered pairs that are associated with them. If this is a unit circle, so what's the radius? 1 unit. Then what would this ordered pair right here be? Oh my gosh. Really worried now. Okay, it would be 1, 0, right? X comes first, then Y. So what would this ordered pair up here be? 0, 1. And what would this ordered pair be? -1, 0, and this one would be 0, -1, okay? So in order to get all the rest of them, we have to understand our trig ratios. I'm wearing my Camp Sohcahtoa shirt today because we're actually doing this in geometry too right now, but a little bit different, obviously. So we want to talk about the trig ratios, and I want to make sure that you remember the 3 that we talked about in geometry. I may have mentioned the other 3 every now. Some years I do and some years I don't because it doesn't really apply to what we're doing, but at least talk about them. Let's draw ourselves a little circle. Oh my God, draw a triangle. I don't even know why I talk sometimes. So all you have learned up until this point is right triangle trigonometry, and that's where we're starting now, but we can apply trig to triangles that are not right triangles. Remember that when you do this, you find the angle that is you're using, right? There's 2 acute angles. One of the 2 are the one that you're actually using for the trig ratios. We're just going to pick this one. Then you label your triangle accordingly, right? This is the opposite side. This is the hypotenuse. This is the adjacent. Is it all coming back to you now? And I don't think you do this at all in Algebra 2, right? Like you don't even touch it? Yeah, I don't think so. Your acronym to remember trig stuff is what? Sohcahtoa, right? So SOH-CAH-TOA. And if you don't spell it right, it doesn't help you at all. There are 3 trig ratios that you get from that. You get sine, okay? So sine of theta, okay? Remember theta just takes the place of an angle. That acronym tells me that sine is always what over what? Opposite over, remember, opposite over hypotenuse. That's what that means. Cosine of theta is always adjacent over hypotenuse. And tangent of theta is always opposite over adjacent. Right? So those are the 3 that we know. The sine, the actual word is S-I-N-E. Cosine is actually S-C-O-S-I-N-E. And tangent is T-A-N-G-E-N-T. So the other 3 are reciprocals of these. Okay? So sine, the reciprocal, is cosecant. Cosecant. So it's 1 over cosecant. Cosine is 1 over secant. And tangent is 1 over cotangent. So if you know the first 3, you know the second 3. No big deal. So sine of theta is opposite over hypotenuse, which means cosecant, and the way that you abbreviate cosecant is CSC. So cosecant of theta then would be 1 over that is just the reciprocal of that, which is hypotenuse over opposite. See? So you already knew them. No big deal. Secant, which is SEC, it's just going to be hypotenuse over adjacent. And cotangent, which is COT, is just going to be adjacent over opposite. So if you can do sine, cosine, and tangent, these are a piece of cake as far as how to set up the ratios. Okay, we good? So I just wanted to introduce them to you today. Having to kind of like put a bunch of pieces together at this point, so that you knew the words, you had seen them, you know how they work, which ones go with which. Like tangent and cotangent, those names at least match. I know secant and cosine, like that just seems weird, but it is what it is. So we've got sine and cosine, secant and cosecant, and just remember that the sine goes with the co and the cosine doesn't, that sort of thing. All right, we good so far? I don't want to cram too much in one day. That's why I wanted to at least introduce these with the rest. It doesn't apply to what we're doing today, and I know that, but I wanted to get that out there so that tomorrow when we start talking about them, they're not brand new with all the other weird stuff. Okay, we good? All right, so you can go ahead and glue both of those in. The assignment that I'm giving you today says at the top, and this I know this is very unlike me, says there should be no work, in little quotes. And that's because we should just know how to do the multiples, kind of like we did on the notes. The last part there, it says find positive and negative coterminal angles. Remember that if there are degrees, to find a coterminal angle, you're adding and subtracting what? 360. If they are radians and you're looking for a coterminal angle, good. You add and subtract 2 pi. All right? No, because we only have 5 minutes left. Sorry. So hope this should go pretty quickly. You know, just think about the multiples. Try and do it without, especially if they happen to be the same ones, same angles pop up that we did in the notes. Try and do it without looking at that stuff. Maybe just jot down what the did I pick up yours already? Jot down what the first quadrant is so that you can see that and you can think through that. And the more you do that and, you know, force yourself to look at it that way, the better off you're going to be. Yes. Yeah, that's a good. Yeah. So in the blank space, you can draw out the circle, but my suggestion would be only draw the first quadrant. Okay? Only draw the first quadrant and try and do it from there, because otherwise all your answers are going to be there. And that's not something you always want to take the time to do, is like draw out the whole circle. But just drawing the first quadrant like we did on the notes, like right here, so that you have that, I would say that is as much as I would like for you to draw so that you can think through it just like we did here. Okay? And then you'll get to the point where that'll kind of be in your head and you may not even need to draw that anymore. But drawing the whole circle, I really don't want you doing that, because that's not going to make you think through it like you need to. Does that help? Okay. Anything else? Those are good questions.